Hello student, today in this video for you, we will cover the following 2 points. First, the equipotential surfaces. Second, the potential gradient. So my name is Aman Sir, I'm mentor at Rubex. If you have not subscribed to our channel, then do it to get amazing videos. And watch our previous videos, the link is in the I tab above. Let us start the question. The figure shows some equipotential surfaces. What will be the magnitude and direction of the electric field? So, to solve this question, we should know the two concepts very clearly. First, what are equipotential surfaces? If this is my equipotential surfaces, then potential difference between 2 points of this surface will be 0, right? And one more property that will be used here is that the electric fields are always perpendicular to the equipotential surfaces, right? Like electric field will not be like this or like this or like this. Okay, it will always be perpendicular to the equipotential surface. And one more thing, the property here is we know that electric field is equal to the negative of the potential gradient. Alright, it means that potential will decrease in the direction in which electric field is increasing. Okay, so these 2 points we will apply here to solve this question. So the question shows the surfaces like this, which are inclined at the 30° of angle. Now, in which direction electric field will be? The question is asking us to find the direction of electric field and magnitude. So electric field can be like this way, or like this way, or in this direction, or in this direction. So in which direction will you choose electric field? To find the electric field direction, we will use the property of equipotential surfaces, which says that electric field is always perpendicular to the equipotential surface. Let us take just 2 electric field for the moment, right? Electric field should be perpendicular to this equipotential surfaces, means it should be in this perpendicular direction, right? This. Why this direction? It should have been perpendicular to like this. Why we have taken electric field in this direction? The question is this. Perpendicular can be drawn in this direction as well, right? But why we have drawn perpendicular in this above direction? So we know that electric potential we are seeing here that decreasing in which direction? It is decreasing in this leftward direction, right? So electric field will always be in that direction where potential gradient is decreasing, right? So we can see that potential per unit length is decreasing in our left direction. That's why electric field will be only in this above direction. Alright, so it is 90° angle and this is 30° angle. It means my electric field direction is, it is making 120° angle with the x-axis, right? So this is my direction of electric field. Now the question is, what will be the magnitude of the electric field? For that, we will use this formula to find electric field. So what is the potential difference between these two plates? The difference is 20 volt minus 10 volt. It is 10 volt, right? So we will write here minus 10 volt. But what is the distance between these two plates? We will say the distance between these two plates is this distance. This is okay, 10 centimeter given to us, but not. This is not a distance between these two plates. The distance should be perpendicular distance between these two plates. So we will draw perpendicular to these plates, right, like this. So if this angle is 30°, then what will be this angle? Obviously 60°, right? So let's say this is point A, this is point B, then what will be this length? It will be AB cos 60°, alright? So distance will be AB cos 60°, right? Means it will be equal to minus 10 upon AB is of 10 centimeter into cos 60 is 1 upon 2. Will be minus 10 upon 5. It means equal to minus 2 volt per centimeter. If I convert it into meter, then what will become? It will minus 200 volt per meter. Alright. So this is my electric field. If I take the magnitude, it will become E is equal to 200 volt per meter. So this is our solution of this question. So thanks for watching. Do like and share and subscribe to our channel for more such amazing videos. To clarify any of your doubts, visit us at www.rubex.in and post your doubts. Moreover, let us know about the concepts and questions you want us to make a video on in the comment box.